Welcome to the last session today, and we would like to invite Prof.Dr.Suntaree Yingjajaval, Center of Excellence on Agriculture, Biotechnology, Kasetsart University, Kamphaeng Saen campus, on the topic Integral Application of Physiology Study in Oil Palm. Please kindly welcome.
Good afternoon, all die-hard participants. Before you go home, I would like, let me take you to the plantation and let's, get to know the understanding how the oil palm works a little better. This also is a story about long-term collaboration between academic institute and a private company. So it's about the work between Kasetsart University and the Nakhon palm oil industry. The work started from 1993 after the typhoon Kamphaeng hit Nakhon area. At that time, oil palm is sort of a new crop in Thailand, and we don't really have any data on it. So most of the information and the cultural practice came from a good neighbor, the Malaysian. So of course, typical question would be, are those know-how applicable to Thailand condition? And CPI want to know this kind of a question that what would be the fertilizer rate? And at that time, the yield is only less than 15 tons per hectare, or about 2 tons per rye. So the income is very low. So they would say, can we cut the cost of fertilizer? That kind of thing. And they have one plantation which they have drip irrigation. So the question is, how much to irrigate? And from the Malaysia, they say, okay, you can leave how many fronds on the tree. Say, is that okay for Thailand? And the oil palm at the CPI plantation is getting older, so they must have a plan to do the replanting, or if they have some thinning, what should we do? And the fact is, at that time in Thailand, most of the people in the field doesn't have the degree in agriculture. So they are a technical person, as a field manager. So this kind of thing needs a lot of basic study. Over the years, the CPI supplied funding for us, to study basic study, which is really tell a lot about their vision. Because as a company, you don't want to know the basic, you want to know how to make money. So we gradually gathering all this data that now we know something in 3 areas, which I will go in more details. First of all, what is the nutrient requirement for oil palm? Well, we don't have data right away at hand. So, but as a soil physicist, we work on the concept of conservation of mass. So I adopt that idea and say, okay, the amount needed for the oil palm would be the amount for growth and the amount to production of the yield. Translate that into fertilizer means that you need to apply fertilizer for what you take out from the soil in terms of the bunch and also in terms of fix up in the tree. And the data at hand would be from our well-established publication for the IPI Bulletin 12, which is tell us what is the nutrient content in oil palm pads and also in the 1 ton of fresh food. All these are studied in Malaysia. Well, we don't have any option, so we adopt their idea and make the some adjustment to fit the fertilizer formula we calculate what it would be the baseline for fertilizer rate annually. And this will be based on the FFB or the ton. How many ton of yield that you have? In this way, the amount of fertilizer will depend on how productivity of the oil palm. We apply ammonium sulfate and rock phosphate, potash, and we apply dolomite, which is a source for calcium and magnesium. Okay. So we use this as a baseline. Say, we need to, in this way, you need to have the data on the yield level of each plot. We use that in the field right away. But as a scientist, you have doubt whether it's really, are you way off? Are you making the right decision? So we need to make a few tests, and we make that at a practical level, not very strictly, statistical analysis kind of thing. But we repeat that for 5 years. And we say we're going to have 4 rates of fertilizer. The one is 100% of what we calculated. So the rest will be, what if we reduce it to 80%, 60%, and we even increase it to 120%, and then collect all the data on the yield. And these two fields seem to confirm that, okay, the baseline that we have still gives the best, the highest yield. One of the plot say that 80% is okay too. But from this we know that, okay, we are in the ballpark. We are not really that far off. So CPI has adopted this formula since that time. As time passed, of course, we want to, have our own data. So we test our own, analyze our own material at CPI. We take the palm, measuring what is biomass, kind of a party in the field. Take every part and then send for analysis. So we are now updating our data and suitable for our own material. So now CPI has established, we have already a well rate for what we have in the field. But you can see that our fertilizer rate based solely on the yield level. So people will say, Ash, what about the soil analysis? Don't you have to know your soil? I said, I don't worry about it. Why so? Because I already knew that in the south of Thailand has heavy rain like this for millions of years. So the rain already washed out all the good things from the soil. The soil is highly rich. It is acidic. It is acidic and very low fertility. Okay. Most of the soil are of the order, we call it altisol. This is low fertility anyway. And the soil for CPI plantation, most of them are low fertility. Means that I'm dealing with a skeleton soil, very skinny. I don't expect any good things come out from this soil. To make sure, we have about 50 sites that we, as a sampling site for leaf analysis. So we take the soil from those sites and measure only the pH to confirm that it's very acidic. And we also confirm that it has low cation exchange capacity, meaning that it has low absorbing power. So if you put nutrient in it, it will be leached away easily. So this thing sort of confirmed to me that the soil there acidic low CEC, and I would say that this is true for all the soil in the southern part of Thailand. Malaysian soil is even worse because they have heavier rainfall. Okay? So to me, the natural contents of soil CPI plantation are too low to sustain a profitable oil palm production. I will not count on this soil to give me anything. Really, do you still want to mine, do the mining, take out nutrients from this soil? Has nothing to give you. So I don't worry about soil analysis. I don't do that in our field. What about leaf analysis? Do we have to worry about it? Well, we did have annual sampling and analyze that, but mostly it's for me to say if I have a problem with deficiency of trace element, I don't use the soil analysis for telling me the fertilizer rate. We analyzed that over 15 years, and we can see a lot of variation in nitrogen, phosphorus, potassium, this kind of thing. But most of them are okay. It's in the optimal or maybe sufficient zone. Okay, but the trace element did tell me that we have deficiency, and it's very persistent. So now we were also adopting the idea that we're going to apply copper and zinc together with boron, maybe every other year even, but at low amount. Now, so I'm not much relying on the leaf analysis, only for checking the health of the tree. And I have a point because, I used to be in the soil department. So should I worry about the analysis protocol? You send the leaf to the lab, you pay money. They give you back the data. They never tell you how accurate that is. Is it reproducible? Is it calibrated? If you send the same sample to different lab, are they going to give you the same number? I worry about that. So what we did is we have a sample each year. We bulk it, and then subsampling it in small bag. And we keep sending this bag repeatedly 5 years. So we send it for analysis this year, the next year, and the next 5 years. The same lab, the same sample, and see how valuable that is. Look at phosphorus from low to high, from low. Is this, what is this? So I'm not gonna rely on this analysis to tell me how to put in the fertilizer rate. And also, in physics, I don't see a way how you can get from concentration to how many kilo per rai for plant. I don't see what to multiply or, what kind of function will you put in there. It's like you have on a yearly basis, you go to the hospital, you have your health check, and they say, okay, the blood would be cholesterol this much and that much. Does it tell you that you can tell how much rice you're going to eat? There's no way of connection to that. So, no, I'm not going to rely much on the leaf analysis. Now, so we already have a comfortable, how to put in the fertilizer rate, but we also know our soil are poor. So we find every ways how to improve the productivity of the soil. One easy way is to add as much organic matter as possible. And we already have this cut plant in the field. So pipe it up, as many plantation already did this. But then we add fertilizer on the plant, on the floor. There are many processes going on. First of all, we're transforming the inorganic fertilizer into the organic form. Means that once you put the fertilizer in the soil, microbes or animals in the soil are going to eat it first before the root. So it changes inorganic into the cell. And then it depends on the cycle of the cell to die off and release the nutrient. So at least you delay the loss of this nutrient from the soil. And by having enough of the nutrient, we speed up the decomposition and recycle rate. Then we also, as an organic matter, as a humans, we improve the absorbing ability of the soil from a low CEC to a higher one. So we retain fertilizer more and longer time. In fact, what are we doing now is that we are creating an area where the root can come in and find food. Under the pile is moisture, it has enough nutrient, it has good pH, so the root will come in. We train the tree to expand the root under the floor, under the pile, where it's all suitable for the root to uptake nutrients. Any kind of organic matter will do. If you are small farmer or big one to go to the mill to send in your product, try to get back something. Ask for that. Now what we found out, the tree here, is that once you have the replanting, the trunk here, this is money in the bank. Because we applying fertilizer to the tree, it been locked up there over 20 years. All these are fertilizer to me. So now you are drawing back the money, and it's really nice because it becomes a slow release fertilizer for you. So anyone from the people in energy comes and say, oh, we need all of this matter so we can burn it and make energy. No. This is money to me. You're not going to take it out from my field. Also make a good mouse. And you see, if you notice enough, you are creating a lively world under the pie. We are training the root underneath there. The root will be attracted. We can also sometimes increase the earthworm. It's a living place. Okay. Now, once we have improved the soil, we already put in the correct amount of fertilizer, we can see, start from the first year. We put the fertilizer rate in this year. The following year, we already see big jump in the bunch weight. 5 kilos per bunch. It's a lot of money. And so over the years, at the beginning about less than 15 tons per hectare or 2 tons per rye, typical. We can up the yield to 3, 4, even 5. Chumpon area is a rather dry place. So on the good years, with good rainfall, it will jump to 6 tons per rye. Are we happy? Of course. Of course. We increased the yield 2 or 3 times already. So I tell you, in the soil of fertility, actually it's a godsend. Because you add fertilizer is easier than you take out a toxic thing from the soil. We can easily buy fertilizer, add to the soil. But one thing, we cannot buy rain. So if in the southern part of Thailand, like in Krabi or something, to have a better distribution of rainfall, except this year. they have drought. But if we have good distribution of rainfall, I would strongly recommend that you increase the fertilizer rate, because then you can maximize the efficiency use of both water and fertilizer. Okay, the next topic will be about the climatic requirement, which is a topic that in fact is a blind spot in agriculture, because we talk about temperature, we talk about rainfall, but we don't really understand effect or the influence. Let me explain some to you. Okay, just a little bit basic. The leaf, will take in CO2, so we consider CO2 as raw material, and take in and fix it. We call that a photosynthesis process. Inside the plant, the water has higher vapor pressure, so it will diffuse out, so the leaf loses water. That we call transpiration. And the stomata then is the gateway for the CO2 to get in and for the water to get out. Now this gateway has to have a sensor to the atmospheric condition, because it has to find a compromise position that I'm going to lose water, but it's worthwhile for the raw material to get in. It has to find the highest maximum efficiency of fixing CO2 against losing water. Okay? So the climatic condition, what are those parameters? Radiation, concentration of CO2. These are driving force for photosynthesis. The temperature of the leaf, we need strong sun, but if the sun is too strong, it will heat up the leaf, it will heat up the air, and will lower the relative humidity. So we call that term a vapor pressure deficit. It's a degree telling how dry the air is. If the air is dry, then the transpiration rate will increase. But all these factors will affect the sensor in the stomata. So the stomata will sense, okay, am I losing too much water now? If I'm losing too much water, then the stomata will close down as a safety procedure. It's like a safety valve. So with this kind of basic, then we start to gathering all the basic data for oil palm. First of all, how good is the photosynthesis of the oil palm leaf? And we find that among the fruit tree that we have data, oil palm is actually working very hard, has very high photosynthesis rate compared to mango, citrus, whatever. Okay. The important thing is that oil palm will need quite a good sun, 700 micromole, meaning that you need to have the sun, you have to see the sunlight. And if it's a cloudy day, it has to be very bright sky. So like yesterday, it's a rainy, it's cloudy sky. Radiation is too low. Today, okay. Maybe a bit too strong, but okay. And the data that we have also confirmed that the oil palm that has high photosynthesis rate will also give higher yield. And the higher photosynthesis rate have a leaf that opens the stomata more than the other one. So the stomata, the gateway, how to get in the raw material is important. We also have the information that a frond, the younger frond from number 9 to 13, has higher photosynthesis rate than the older one. So if the frond is greater than 40, to me, cut them off. Not worth keeping it. So you leave only 40 frond on the trees, okay. When the tree is getting older, it has shedding. So this is when people start thinning out, taking out the palm, you know. We did make the measurement with the quantum, and we measure 4 directions at several depths, you know, several heights on the tree to see how serious is the shedding. And then we sort of play around with the thinning plant. If it's not serious, to take out a few, you know, the red dot there is the tree that you cut out. And let the sun shine to all the rest, you know, that surround it. So we can cut 11%, and then the shading, when it becomes serious, we can increase it 25 and to 31. This kind of thing. And we agree with most of the practice that in replanting, you cut every other 2 rows is okay too, you know, in terms of sunlight. Don't keep your young seedling under the old tree too long. 1 year is enough. Especially in the south, and you go further south, it's very cloudy, so the younger one do not have enough sunlight to grow. Apart from radiation, we also measure, we know that CO2 is a raw material, so we want to know if we can increase the photosynthesis by giving more CO2 to the plant. And by nature, CO2 is high before the sunrise because every living thing will breathe out CO2. So CO2 is quite high, about twice the normal rate before the sun comes up. Once we have the sun, the green leaf will take in CO2 for photosynthesis, and so the concentration drops down very quickly, become limiting factor to photosynthesis. So if we increase the CO2 in the air, we can increase the photosynthesis rate. There's a way to do that. So if you want to keep the seedling stronger, more healthier, there's a way to do it. Then we like to know how it's worked throughout the day. So we measure every hour and 3 seasons in a year. Okay? And these are some of the data. I'm not going to get more to it, but the example is this. One chart is in Chumpon areas. The air is quite moist. Moister than Kasetsart, which is in Pathom. And Kasetsart is rain-fed, this one with drip irrigation. So you have water in it and the air is moisture. So you can see that in December, the leaves in one charm area seem to be working almost throughout the day. But in Kasetsart, it was working only 2 hours in the morning. What they are doing? Sleeping most of the day. Why so? Because the stomata open very narrow and only 2 hours. Once you get into the prolong from the end of the rainy season to a very dry season to March, you can see that the photosynthesis greatly reduced. It's almost not working at all. And only for a short time in the morning. Why? Because that's only the time the stomata open. Why? Because the air is too dry. So this is why we are saying that if you have a dry place, the pump probably not working throughout the day. What can it do? It has to take out the food that's already stored in the trunk and just to keep living. So it means that, of course, the pump in the Wanchan area would have the growth almost throughout the year, but in the drier place, it's grow only in the rainy season. In the rainy season, you hardly see any difference between these two cases. The leaf will do, almost as active equally. So we have the idea now that the climatic condition in terms of the dryness of the air, in terms of high temperature and low relative humidity, it will dictate the opening of the stomata. Okay? And if the sun is too strong, it heat up the leaf. So the leaf, when it's very hot, it will tell the stomata to close down. We also study the water status in the leaf, tell the balance of water in the leaf. From this, we can tell that once you get into the midday, it's very warm, it's very hot, and the leaf will lose water. It loses water faster than the root can supply it. So the water status in the leaf is really sort of very dry up during the day. It's good in early morning, but then during the midday it will dry up and will recover only in the evening. Now, with this kind of understanding, we have a case later on that, okay, in Thailand, people can grow palm in Langsit area. But we already know, say that the commercial oil palm is grown, plus or minus 10. Dr. Krisada says 7, but okay, say extend it to 10. Of the latitude, plus or minus. But Langsit area is only 14. So is this okay? Some people even grow it in Chiang Rai. So the Langsit area has some kind of a special landform. It is a flooded rice field. But the farmer themselves reshape the land. They build polder around their plot, and they dug up, make a raised bed and water in the ditch. So it's a condition of soil water unlimited. And they say, this is good for oil palm. And they start growing it. And it's very good, you see, 3 years old, it's very big. But we know that at that latitude, the air is really very dry, much drier than in the south. So in studying that, we particularly have to pay attention to the climatic condition. So we install the climatic station. We measure temperature and relative humidity profile up, to 6 meters. Is the height of the oil palm tree. And we measure what's the activity of the oil palm throughout the day. We found that in Langsit area, the palm works only half a day. Only half a day. Why? Because the stomata open very good only half a day. And especially very good at about 10 o'clock, and then it just, become lazy. The water status also tells us that even though we have water in the root all the time, but that water cannot go fast enough to replenish the leaves that are losing water. So the soil water is not really what we think they can help. In short, we can summarize the data from the Langsit area that, again, the dryness of the air is really control the opening of the stomata. And the opening of the stomata tells how good the leaf can photosynthesis and how good it can do the transpiration. With this kind of thing, then we now know that we have a condition that are good for the leaf to photosynthesis, and that is you need to have radiation higher than 700, and the air must not be too dry, so the VPD less than 2 kilopascal. Now, we have data, we record that. So we calculate how many hours in the day that have meet this condition. Okay. So in Chumpon plantation, CPI in China area, this is the green one. We can see that actually the longer hour, the longer working hour occur in April to July, early months of rainy season. The leaf work better. Why? Because this year that happened to have good rainfall. So the air is not too dry, the stomata open. And once the rain stops, the sunshine, have good sunshine. So actually, early before the rainy season, the pump's working very good. When you get into the middle of the rainy season, August to October, the working hour become less. Why? Because it's rain most of the time. It's really cloudy. So the sunlight is not enough. And then when it's not raining, the sunshine is very strong. It's really hot right away. So the stomata closed like that. But once you get into the winter time, it's even worse because it's very dry and the stomata closed most of the day. See? Okay, the lancet area, because it was dry most of the time, so the working hour of the palm in lancet area is only half of what happened in the south. Okay, you said, Ajahn Suntaree, we know that, so what can we do? Nothing. You cannot change the climatic condition in the field, right? But you actually can add CO2, right? But the environmentalists will not love you. They will complain. No, you cannot burn. See? But you can add CO2 and increase the photosynthesis. However, in the nursery, you can modify. It's under your control. What you can do the fog spraying to increase the moisture in the air. You can have a system of watering to the soil. Okay. So this is sort of still playing with the idea. It's a prototype. We haven't get it working yet. But you see, so you have a movable saline. So on a sunny day, you cover it up. On a cloudy day, you open it. So to adjust the radiation. And then you have the fog here, spray to increase the moisture so the stomata can open. The water in the soil, you separate it in a different system because the water in the soil, you doesn't have the same amount with the fog spraying. And this watering system is spraying. You can actually use this system and connect it to a CO2 tank. So you open up the CO2 in the morning, 1 hour, increase the photosynthesis, and then later on, if you need water to the soil, you just turn on the valve, switch to water. This kind of thing. If the electricity is cheap enough, you can even add, LED light or something. Okay. The third one is about the water use of the oil palm. This is because CPI plantation has, one of the plantation has a drip system. So they would ask me how much water should you irrigate, which is very funny because if you install 10 million baht for this, the company that installed it has to tell you. Because before they install it, they have to cut some number, how many liters of palm you need. See? But not that you installed it and ask me how many liters should I put in. It's really funny. But anyway, so in order to make it more of accuracy, so say, okay, you install equipment to measure the water content and to measure the water potential, we call temperature. And of course, we have the information about the soil. We also install a rain gauge, a pan evaporation, and a climatic station there. Now, these are the data we have. Down here is the soil water status. And the way I plot it means that we have tensiometer at 10 centimeter depth, at 30, 60, and 90, and 100. So we install the tensiometer at various depths. And we make the reading every day throughout the year, 365 days. And we have the data on the pan evaporation. We have the data on the rainfall. And we have, this plantation has a drip irrigation. You drip 200 liters per day per palm is about, it's equivalent to about 2 millimeters of rainfall. So that much amount really cannot be compared with rainfall. Now, what we see from here is very interesting, is that you see in the dry season, no rain here, in the February to March, something. In the dry period, but the soil profile was wet. In the dry season, the soil profile was wet. In the rainy season, when you have heavy rainfall, the soil profile was dry. This is very funny, right? The only explanation is, in the dry season, because it's very dry, the stomata closes down, there's very little transpiration. If there's very little transpiration, there is no root uptake. The root doesn't take up water. So if you irrigate, you just wet the profile. Okay? But in the rainy season, the leaves are actively, the stomata open, so it takes up a lot of water and it dries up the profile even though you have heavy rain. In Ramsit area, we did the same thing, we kind of start to have some fun now. So we installed the equipment to measure the water status there. Every, 10 centimeters into the profile. And this is what we got. Again, we can see that during the dry period, but we can still see a wet profile throughout. Why? Because at that time, the air above the tree was dry. So when the air above the tree was dry, with a little transpiration, so there's no root uptake, and water from the dish get into the profile and it's wet. See? Another case is that, so during the rainfall, if we have a rainfall, again, the root zone was wet. Even though the air above is moist, but the transpiration was low. So the root uptake was low. Then the profile wet again. So you can have a wet profile in the dry season, you can have a wet profile in the rainy season. But this one, they have to be careful, is that in the rainy season, it's really very wet for 3 months. So the root is sort of submerged, saturated. So when we present this data, so the grower now in Nakhon area, they will start to pump water out from the field in the rainy season, try to get the air in. We also, play along with the, we call it a root scanner. You put it in the soil and they take the pictures, of the root underneath. We actually see the water level there. So it's confirmed that water from the dish is flooded, And for 0.58 to 7, it's 2.5 years past. He's sort of disappointed the root doesn't go out that much as we expect. This is the kind of thing. So with all this knowledge now come to the practical point of then if we have an irrigation system, when to irrigate and how much. My practical answer would be, okay, let's take the protocol. Okay, first of all, you define the active root zone. Doesn't have to be accurate, But from our study, we found that the active is about 60 centimeters to 80. So let's say 60 to 80. Then, apart from invest in your irrigation system million of baht, buy 2 10 kilometers, 10,000 baht each nowadays, I would think. Okay. Then install this in the profile. The first one at 1/4 of the root zone, at the depth of about 15 to 20. The other one is at the 3/4 of the root zone. Okay. The first one, if the needle go above 30, then start to irrigate. Then the water will just move down the profile, and it's when it gets to the second one, the needle of the second one will start to fall down, drop down, meaning that the water now reaches this depth. Then you stop irrigate. How many liters? It depends on what water is left in the profile. The reason they are doing this is that so the first one, tell how active the root has taken up water, so it dry up the soil, so you start it. And then the second one is to that, so you don't have to waste away water. Once the water reaches here, it will take some time to fill up the root zone, but not more than that. So you do not waste away water. CPI, they install not just 2, they install 4. For my study, we use 9. So CPI, invest about 10 million baht in the drip irrigation system at that time. They have about 10,000 lives. So they bought 100 watt tensiometer and installed in various places. Another point is because they have drip irrigation in 2 plantations. One at the beginning in 1984, they already have the irrigation system installed. So we start to take data on the plot which has drip and the plot that's rain-fed, and you compare between the 2 plots in a first approximation. This time here is hit by typhoon, so we start again. But anyway, CPI 5 in Wangchang area has a much moisture in the air, and the land is quite uniform. So we can see that there's an average increase by irrigation of 36%. Now you have to consider, is this 36% worth it? Worth the investment, And the best year is to irrigate on the drought year. When it's very dry, you irrigate, you have a big jump, like that. But if it's a wet year, the irrigation doesn't help, of course. In the dry plantation in China area, and the land is not so good, but because it's very dry, the irrigation system only increased the yield 8%. So don't expect a miracle. There's a lot of misunderstanding about irrigation, so let me explain. The air is sucked up. You may try to move the water from the leaf. If the leaf stomata open, then the leaf will lose water, and then it will cause the root to uptake. Okay. In this way, you irrigate, makes sense. You replenish the soil. But if VPD is very high and the stomata grows, transpiration limited, there will be very little root uptake, why irrigate? You only wet the soil. Okay? So for us now, the idea is if your water supply is limited, be conservative. Rather than giving 200 liters, maybe 50 is enough. But 50, okay, a minimum rate, so your water supply can last throughout the dry season. It's more important. In conclusion, oil palm is a fast-growing tree as compared to other fruit trees. And what you harvest out is oil. And oil requires the highest construction cost. It's not like sugar cane, which is sugar. It's not protein, it's oil, which is expensive for the plant to synthesize. So oil palm will require very high input, means that the leaf have to have good photosynthesis. Means that the sunlight has to be enough, meaning that the stomata has to be open as much as possible, as long as possible. Okay? Then you need to supply sufficient amount, enough, and all the necessary nutrient. In the soil, they call it essential nutrient. Essential means you cannot live without it. And one element cannot substitute for the other. Okay? So you add, for example, you add ammonium sulfate. Ammonium sulfate gives you nitrogen and sulfur. You add phosphorus. You add potassium chloride. You add glyceride. Iron and manganese is in the soil, plenty enough, so you don't worry about it. You add boron. What about calcium? Did you put in calcium? Do you put in dolomite? Why not? In the south of Thailand, with a lot of rainfall, you don't have calcium in the soil. That's why it's acid. If you're gonna put in NPK, remember you have to put in calcium, magnesium, and sulfur. It's a must. Then, if you add boron, add copper and zinc as well. Okay? So that's about the nutrient. The root uptake of water depends on what's on top of the plant more than what's in the soil. That's what we get from our data. So in order to increase the yield, is whether that yield production of oil palm is feasible, there are pertinent points. One, don't talk to me about the annual rainfall. It doesn't mean anything. Because in Thailand, the rainfall, you can grow anything during rainy season. You can grow anything. But oil palm, you have the bunch throughout the year, every month. So where can you grow it? Do you have rainfall every month or not? What is the duration of your dry months? That limit your production. Okay? Even though you can say, we have water to irrigate. Your irrigate in the water has no effect on top of the tree. It cannot help open up the stomata. The photosynthesis is limited if the stomata doesn't open. Okay? And oil palm, it has to have a good growth, vegetative growth first. So you have to give fertilizer enough to have a strong, healthy plant. Then the surplus will get into making bunches. If you don't have enough fertilizer, you can only have the tree. So you have decorative palm. And besides that, the bunch formation, the floral bunch, depends on what's on top of the tree. Okay? So from this data, we are very happy that, say like I think 10 years ago, the Thai government is thinking about expanding oil palm to the northeast. 500,000 rai. And I was sort of involved in that, so I give a report and say, I don't think that with the dry condition of northeast, you can grow oil palm commercially. I'm very glad that the government put a stop to it. Otherwise, I'm thinking that we save the farmer from debt about $1 billion, 1,000 million baht already. So, as you can see, all this basic data finally get into the national policy. We don't have to wait and see. If we don't start have the data, they will say, okay, we can grow in the northeast. Let's try do it. I said, why try? I can tell you that you cannot grow it. From our data, we have studied this for a long time. See what I mean? This is the end of it. You can see that we did a lot of research throughout the year. I cannot do it myself. So I really want to show appreciation to the Kamphaeng palm oil industry and its subsidiary, the CPI Biotech, for their generous funding to the university. And they really I really admire their vision, because at that time no company would give money for basic study. And I think it's high time in Thailand that the private sector should invest in their own data generation and data compiling. Don't wait for the government. It will be forever. If you think like the American, then what is your income? How many percentage should you invest for future? Okay, I would like to thank Kasetsart University for the generous giving me on the researcher assistant and the lab equipment. And finally, for the hard-working assistant, CPI co-workers, and my member in the lab, it's really fun to work with them, so I still enjoy up to now. Thanks for your time.